Welcome back to the deep dive. We are doing something a little different today.
A little bit, yeah.
Usually we take a whole stack of articles, maybe a few different books,
Yeah.
and we try to, weave a narrative thread through them. We're the synthesizers.
We pull the golden threads from all over the place.
Exactly, and try to make a tapestry. But today we are grappling with a monolith, a single, massive architectural document.
Yeah.
We are looking at the master manuscript of Thomas Locker's The Fractal Core.
It is a dense one. I have the file open right here. It's a version 3.1, and honestly, just scrolling through the table of contents, it feels like looking at blueprints for a cathedral or something.
It does.
It's heavy, conceptually heavy.
It really is. The subtitle alone gives you a hint of the ambition we're dealing with. Maps, not terrain. How boundaries and inference create space, time, self, and truth.
Right. It's not a small claim.
Not at all. And our mission today is very specific. We aren't just, browsing this thing. We are going to attempt to build what Locker calls the reality stack.
Which is essentially a ladder, a 10-step ladder. And the goal is to rebuild the universe from the absolute bottom up.
From scratch.
From scratch. And I want to be clear right from the get-go, this isn't just abstract philosophy. Locker is an engineer at heart. He is building a specification.
That's the part that hooked me. He treats reality like a software stack.
Yeah.
And frankly, for everyone listening, you need to be prepared because we're going to ask you to visualize this with us.
Yes.
We are effectively building a mental infographic today. So imagine a blank canvas in your mind, and by the end of this, we're going to have 10 distinct layers drawn on it. And these layers are going to explain everything from, why atoms stick together, all the way up to how we should build the next internet.
Exactly. By the time we get to the top of this ladder, we aren't just going to have some new pet theory of physics. We're going to have a blueprint for digital identity, for AI, for, how we structure society.
It's an architectural spec.
It is, for what he calls individually centric systems.
Okay, but before we can even start climbing, we have to talk about the ground we're standing on. Or maybe the ground we think we're standing on. Locker starts with this incredibly provocative hook. He says that the things we assume are the terrain of reality, space, time, objects, even our own sense of self, they're actually just maps.
We live inside maps. That's the line that just jumps out, right? It's on the back cover.
It lives inside maps.
It sounds a bit like the Matrix or some simulation theory, but he means it in a very specific, almost technical sense, doesn't he?
Oh, completely. And this is so crucial for setting the stage. Locker isn't writing science fiction here. He's arguing that what we perceive as reality is a user interface, a UI.
Okay, like on my computer.
Exactly like on your computer.
Yeah.
You see folders, files, a trash can. That is a map. It's what allows you to use the computer. But if you actually looked at the terrain, the raw voltage states in the transistors, the binary code flipping millions of times a second.
I couldn't do anything. It'd just be noise. It would be total noise. You couldn't function. So the operating system creates this convenient fiction, a folder, to help you interact with the underlying reality.
And Locker's argument is that space and time are the desktop icons.
They're the icons, not the voltage. They are interfaces that we evolved to survive, not the fundamental truth of the universe.
That is a brain-breaking way to start a book. So if we're all living in the interface, the whole goal of this thing, and our deep dive today, is to sort of peer underneath the desktop.
To see the code, to see the raw voltage.
All right, so let's unpack the rules of the game before we start the climb. Locker has this concept in Chapter 1 called the rebuild rule. And it sounds strict, like really strict.
It is ruthless. And honestly, it's what makes this manuscript so difficult to get through at first, but it's also what makes it so rewarding if you stick with it.
Okay, so what is it?
The rebuild rule basically says you cannot smuggle in the assumptions you are trying to explain.
No smuggling.
No smuggling. So if you want to explain how time works, you cannot start your theory with a clock. You can't start with a variable t that just magically changes.
You can't assume time to explain time.
Right, and if you want to explain space, you can't start with a coordinate grid or some empty background container. You have to start with nothing but the raw materials and then build space and time out of them.
That feels incredibly difficult. It's like trying to explain language without using any words.
It is, but it forces what he calls structural honesty. If we don't follow this rule, we just end up with circular logic. We say, time flows because it is in the equation. Locker says, no, you have to earn.
You have to earn. I love that. Okay, so let's look at our mission map. We have 10 steps. We are going from the absolute bottom, the raw foundation, all the way up to truth at the very top. So listener, get that mental whiteboard ready. we are drawing the very bottom layer.
Let's do it.
All right, body part 1, the foundation. This is steps 1 through 3. This is where we clear away all the rubble. Step 1 is maps and models. He calls this the discipline phase.
This is where we learn to separate what is actually real from what is just accounting, bookkeeping.
And he introduces this foundation test in chapter 1. He says, and I'm quoting here, if a concept disappears when you change your unit of measurement or your coordinate system, it is not a primitive, it is bookkeeping. That feels a little abstract. Can we ground that in something real?
Sure. Think about the meter. A meter is a unit of length. If aliens landed tomorrow, they wouldn't have the meter. They might measure distance in, I don't know, Zork lengths.
Right.
If we switch from meters to Zorks, the number changes. The concept of 1 meter just vanishes. That means the meter is an artifact of our map. It's not a feature of the terrain.
Okay, that makes sense. Units are arbitrary. We made them up. But he goes further than that, doesn't he? He's implying that distance itself might be bookkeeping.
He is. And this is where it gets really uncomfortable for our intuition. His point is, if you can describe an entire system purely by talking about relationships, how strongly A is connected to B, how much A influences C without ever mentioning inches or miles, then distance is just a convenient way for us to visualize those connection strengths.
It's an accounting tool.
It's an accounting tool. It's useful, but not fundamental.
So the foundation test basically strips away everything that is just human accounting.
Yeah.
It's asking the question, what is left when the accountant goes home for the night?
Exactly. And for Locker, the answer is very, very little.
Which leads us perfectly into step 2, the primitives, or as Locker calls them, the hard survivors. These are the things that actually survive that test.
These are the things left in the room.
So if we're drawing our infographic, this is the bedrock. This is the absolute foundation.
These are the bedrock ingredients. When you strip away the map, the coordinates, the clocks, all the labels, what is actually fundamentally there, Locker says there are 4 ingredients.
Okay, let's run through them. Ingredient 1, relational structure.
This is the absolute bottom of the bottom. The only thing that matters is differences. It doesn't matter what state you are in, absolutely. It only matters how you relate to other states.
Give me an analogy.
Think about a choir.
Okay, I'm picturing a choir.
It doesn't matter if everyone is singing in the key of C or the key of G. As long as the intervals between the singers are the same, the relative pitch difference between the soprano and the bass, the song is the same song.
Right, I'd recognize the melody either way.
You'd recognize the melody. The absolute pitch doesn't matter. The relation creates the reality of the song. Locker argues the entire universe is built on these relative differences. Phase, amplitude, orientation, coupling. It's a symphony of differences, not a collection of static things.
So reality is the song, not the individual note.
That's a great way to put it, yeah.
Okay, ingredient 2, normalization. He calls it the unity constraint. This sounds really mathematical, but I have a feeling it's vital for things to, actually exist at all.
It is, but the concept is actually pretty intuitive. Imagine a balloon. If you don't have a skin on the balloon, the rubber, the air just disperses. It becomes part of the atmosphere, so it's gone.
It's no longer a balloon.
It's no longer a thing. To have a thing, anything, you need a bound. Normalization is the mathematical way of saying this all holds together as one coherent unit. It's the one in the equation that keeps the system from dissolving into infinity or shrinking down to 0.
So without normalization, you can't have separate objects.
Yeah.
Everything would just be soup.
One big undifferentiated soup. Precisely.
Yeah.
Normalization is the glue of coherence. It's what allows us to point at something and say, that is an object, rather than just, that is a patch of the universe.
Okay, that makes sense. Ingredient 3, topology. Now, I always think of topology as that thing where a coffee mug can turn into a donut.
That's the classic example, and it applies perfectly here. Topology is the study of properties that don't change when you stretch or squish something. Think of a loop of string. You can make that loop into a circle or a square or a triangle. The geometry changes, the angles, the lengths of the sides, they all change. But the fact that it is a closed loop, that never changes.
Right. You'd have to actually cut the string to change that.
Exactly. You'd have to break it. Looker's point is that because our maps always distort things, like how a map of the Earth stretches out Greenland and Antarctica, we can't trust geometry. Geometry's flimsy, but we can trust topology. If there is a knot in the data, that knot is real.
The knot survives the stretching.
The knot survives.
And finally, ingredient 4, boundaries.
The separation of inside from outside. This seems obvious, but it's fundamental. Without a boundary, you don't have an object. You just have that relational soup we talked about. The boundary is what carves a thing out of the soup.
And this brings us right to the title of the book, doesn't it? The fractal core.
Right. This is the visual I really want you to hold in your head for the rest of this deep dive. Imagine these boundaries nesting inside each other like Russian dolls. You have a tiny boundary, let's say it's a single cell. Inside that cell are even smaller boundaries, like the nucleus, the mitochondria. But the cell itself is inside a larger boundary, like an organ, say, the liver. And the liver is inside a body.
And the body is inside a house, which is inside a society.
Exactly. That is the fractal core. It's this nested hierarchy of boundaries. And here is the key insight from Chapter 3, structural renormalization.
That sounds like serious jargon. We need to unpack that for the listeners who are drawing this chart in their heads.
It sounds scary, but the concept is actually simple. It just means summarizing upward.
Summarizing upward.
It means that the higher level cannot see the details of the lower level. It's physically impossible. Your brain doesn't know what each of your individual liver cells is doing right now. It doesn't track their chemistry, their mitochondrial function.
That would be way too much information.
Way too much. Your brain only gets a summary report from the liver boundary, a message that says, I'm filtering toxins, or help, I'm failing. The boundary forces a summary. It's a bottleneck.
So reality is basically a giant cosmic game of telephone played upwards through these layers of summaries.
In a way, yes. Information gets compressed and coarsened as it moves up the stack, and that compression is what allows us to exist at all. If your brain had to track every single atom in your liver, you'd crash. You wouldn't have the bandwidth to think or run from a lion.
That leads perfectly into step 3, constraints. Because these primitives aren't just floating around randomly, they have to obey rules. This is the final layer of our foundation on the infographic.
Correct. The ingredients aren't enough. You need the rules of the game. Loker talks about two big ones, coherence constraints and propagation constraints. And the key is, these rules are set before the game board of space and time even exists.
So this is where something like the speed of light comes in. Because usually we think of the speed of light as a speed limit through space.
It is. But in Loker's framework, since we haven't built space yet, it can't be a speed through space. It has to be something more fundamental.
So what is it?
It's a propagation constraint. Think of it like a bucket brigade putting out a fire. You have a line of people passing buckets of water. The water can only move as fast as the buckets can be handed off from person to person.
Okay, that makes sense.
The speed limit isn't a property of the air or the ground or the distance. It's a constraint on how fast the buckets, the relations, can update each other. The speed of light is just the fundamental refresh rate of the universal bucket brigade.
So we have our foundation. Relations, boundaries, and rules. We don't have space. We don't have time. We're in this sort of structured void. That's the bottom chunk of our infographic.
Exactly. We are effectively in the machine code of the universe. Now we need to boot up the operating system.
Which brings us to body part 2, the interface world. Steps 4 and 5. This is where the world we actually recognize starts to appear on the ladder. Step 4, interfaces, space, and time.
And here is the big reframing. Host, if I ask you, where are you right now, what do you say?
I'd give you my street address, or, my GPS coordinates if I was being fancy.
Right. You treat space as a container that you are sitting inside of. You treat it like a big, empty box. And Loker says, stop, that's wrong. Space is not a container. Space is the geometry of compressible coherence.
Okay, I am definitely going to need the analogy for that one. How do we visualize space if it's not a box?
Okay, imagine you are at a really loud cocktail party.
Been there.
You're standing right next to me so we can hear each other perfectly. Our conversation is clear. We are coherent. We're sharing information easily. Now imagine someone across the room is shouting something. You can barely make out what they're saying. They are incoherent relative to us.
Right, they're just noise. I'm with you.
Now imagine we decide to draw a map of this party, but we don't draw it based on where our feet are physically standing on the floor. We draw it based on who can hear whom. If I can hear you clearly, I put our dots right next to each other on the map. If I can't hear Bob across the room, Bob's dot goes far, far away on the page.
So distance on this map is just another word for how well we're communicating.
Exactly. Near just means highly coherent. Far just means incoherent. Loker's argument is that if you map out all of those relationships for the entire universe, every particle talking to every other particle, you get a geometry. You get 3D space.
Well,
Space emerges from the relationships, but the relationships don't happen inside of
so
space.
the relationships come
The
first.
relationships come first, absolutely. This, by the way, explains why something like quantum entanglement feels so weird to us.
Right, because you have two particles that could be miles apart on opposite sides of the planet, but they act like they're instantly connected.
You nailed it. In Locker's model, entanglement isn't spooky action at a distance. It's just that our map space says they are far apart, but the terrain, the underlying coherence, says they are right next to each other.
The map is lying to us.
The map is a bad representation. The desktop icon is in the wrong folder.
Wow. That completely changes how you view physics. It's not magic, it's just a bad user interface. Okay, what about time? This is still step 4. Locker calls time bookkeeping.
Chapter 5 is just brutal on our romantic idea of time. He says, time is not a river. It does not flow. It isn't a fourth dimension that you travel through.
Then why does it feel like it flows? Why do I get older? Why does my coffee get cold?
Because you are a bounded system. Remember the Russian dolls, the castle wall. Because you are inside a boundary, you cannot process all the information in the universe at once. It's impossible. So you have to process it in chunks. You take in an input, you process it, you create an output, then you do the next one. Input, process, output.
Like a computer's processor cycle. Tick-tock.
Exactly. That sequencing, that ordering of events creates an index. Event 1, Event 2, Event 3, Event 4. That index is what we perceive and call time. There's a great catchphrase in his notes here. Time is the coordinate of sequential inference.
The coordinate of sequential inference. That is heavy.
Think of it like reading a book. The story in the book isn't moving. The book itself is static. It's just sitting there on the shelf. But you, the reader, can only read one word at a time. The flow of the story is actually just the movement of your attention across the page.
So time is just the page number of my thoughts.
It's the page number of your inference, yes.
Okay. So on our infographic, space and time are the user interface. They're the desktop. We place those at step 4. But then step 5 is intrinsics. If space and time are basically made up, what about an electron? What about things like charge and spin? Are those made up too? They feel very real.
And they are real. This is where the topology from step 2 comes back to save us. Locker argues that while position in space is just a map coordinate, things like charge and spin are intrinsics. They are real because they are topological, not geometric.
Okay, give me the visual on that. How is charge a shape? I think of it as just a plus or a minus sign.
Think of it as a winding glass, like a knot. Imagine you have a long extension cord. You can stretch that cord all the way across the room. You're changing its geometry. But if there's a knot tied in the middle of it, the knot is still there. You can't stretch the knot away.
No, I'd have to untie it.
You'd have to untie it. The knot is topological. Locker says charge is basically a knot in the phase of the system's underlying field.
So an electron isn't a tiny marble with a minus sign painted on it. It's a persistent knot in the fabric of reality.
Exactly. And spin. Spin is an orientation class. It's about how things twist and relate to their surroundings. And this explains that famous mind-bending concept from physics called the 720-degree return.
I remember this vaguely from college. It's the idea that some particles have to spin around twice to get back to where they started, which makes no sense if you think about a basketball.
Right. If you spin a basketball 360 degrees, it's back to the start. But if you think of spin as a topological twist, like a ribbon, a Mobius strip almost. Host, if you hold a ribbon flat in your hand and I twist one end 360 degrees, you create a tangle in it.
Okay, yeah, I can picture that.
To get that tangle out, you actually have to twist it again, doing a full 720 degrees, to loop the tangle out and return it to the original smooth state. That persistence is what spin is.
So the big takeaway here is geometry things like distance and duration changes depending on your map, on how you look at it. But topology, the knots and the twists, persist no matter what. That's why charge and spin are intrinsics.
Exactly. They are the hard survivors that ride up the elevator of the reality stack. They are the actual data that the desktop icons of space and time are trying to represent.
We are halfway up the ladder. We've built the physics of the universe. We understand the interface. Now we hit body part 3, the self, step 6 and 7. This is where it gets personal. This is where we enter the infographic.
This is the big transition from physics to agents, from, rocks to minds.
Step 6, individuals. Locker defines an individual not as a person, but as a, get this, boundary-stabilized relational substructure. That is a mouthful.
It is. But let's just go back to the Russian dolls, or the idea of a castle. An individual is just anything that has a stable boundary that separates me from not me. A cell, a person, a company, a nation.
And he brings in this idea of the Markov blanket here from statistics.
Yes. A Markov blanket is basically the formal term for this kind of informational boundary. Think of it as a castle wall, but a castle wall with messengers. The king, inside the castle, that's your internal state, cannot see the enemy army outside. He can't see the external world directly.
He can only read reports.
He can only read the notes passed to him by the guards on the wall, his senses, and he can only send out orders via those same guards, his actions.
So the king is totally isolated.
He's isolated, but he's also protected. And this isolation is the crucial step. This is what creates a viewpoint. Because the king can't see everything, he has to guess. He has to build a model. He has to infer what is happening outside based only on those little notes.
And that's the birth of the self.
That is the birth of the self. The self is just any system that has to guess about the world because it is stuck behind a wall.
That is profoundly lonely in a way.
Yeah.
But it also explains why we all see things so differently. We're all stuck in our own castles just reading different notes from the guards.
Exactly. And that leads directly, inevitably, to step 7, identity. If I'm just this king guessing behind a wall, what is identity? And Locker says it is not a record. It is not a database entry. It's not your name.
This is a huge shift in thinking. We usually think of identity as a name tag or a driver's license. I am John Doe, born in 1980. Locker says no. Identity is normalized persistence.
He changes the question from who are you to are you persisting?
It's a verb, not a noun. Identity is something you do.
Right. Identity is the active process of keeping the castle wall standing. It's the ongoing work of maintaining coherence against the entropy and chaos of the universe. If you stop maintaining that boundary, you dissolve. You literally lose your identity.
And this introduces the confidence corridor. I love this visual because it feels so human. Let's paint this on our infographic.
This comes from the confidence principle in Chapter 9. Because the king is always just guessing, he can never be 100% sure that he's safe or that his model of the world is right. He has to operate on probability. I am 99% sure the walls are holding. Identity is a probabilistic belief about your own persistence.
And the corridor is the range of that belief, the margin of error.
Exactly. Imagine a hallway. The width of that hallway represents your uncertainty. If you have lots of good, coherent evidence that your memories fit together, your body feels right, people you know recognize you, the hallway is very narrow. Your confidence is high.
But if I wake up with amnesia?
The hallway blows wide open. You don't know where the walls are. You aren't sure if you're safe or even who you are. Your confidence in your own persistence plummets.
Okay, so why does this matter for technology? Locker makes this huge point that this has to be individually centric. What does that mean architecturally?
This is the critical architectural point of the entire book, I think. Identity must be computed at the boundary. The king inside the castle has to be the one to decide if he is safe. He cannot outsource that decision. He can't call up a neighboring castle and ask, hey, am I safe? The neighbor doesn't know. The neighbor can't see inside your walls.
But that's exactly how the entire internet works right now.
Exactly. When you log into a website with Google or Facebook or Apple, you are effectively a king asking a distant corporate castle, hey, am I me?
And Locker is saying that fundamentally violates the physics of reality.
It violates the reality stack. It outsources the one and only thing that must be internal, the maintenance of your own boundary. And this means that our current digital identity systems, the ones that rely on a central server to tell you who you are, they are structurally flawed. They're brittle. They're destined to fail.
That is a mic drop moment for the entire tech industry. We've been building identity completely upside down. We'll come back to the frictionless existence idea that comes from this.
Yeah.
But we have to keep climbing. Body part 4, mind and society, steps 8 and 9.
Step 8, consciousness.
Okay, this is usually the part in books like this where authors just wave their hands and say, and then magic happens, or quantum magic. But Locker claims it's just the same engine higher up.
He demystifies it so beautifully. He says consciousness isn't some new magical substance that gets sprinkled in. It's just what happens when you stack enough of these identity-maintaining, self-modeling loops on top of each other.
The Russian dolls again.
Yes. Let's just look at the layers of this particular doll.
Yeah.
Level 1, simple persistence. A rock persists. It holds its boundary against erosion. It has a basic form of identity.
Hierarchical integration. A thermostat persists and it reacts. It has a tiny little feedback loop to maintain a state.
Self-modeling. This is the kicker. This is the ego.
The ego is a model.
The ego is a map of the mapmaker. It's the king in the castle, not just modeling the army outside, but turning his attention inward and modeling the castle itself.
Right.
He starts thinking, I am a castle that is currently under attack. Once you have a system that models itself as part of its strategy to survive, that's consciousness.
So it's recursion. The system is looking in a mirror to better predict its future.
Precisely. It's an internal feedback loop of self-representation.
Okay, but what about qualia? The raw feeling of seeing red, the taste of coffee, that's the hard problem that usually stumps the engineers.
Locher has a definition for this too, and it's a wild one. He defines qualia as the internal signature of globally integrated coarsening.
Okay, you're definitely going to have to unpack integrated coursing.
Let's go back to data compression. Your brain has millions of inputs coming in every second. Photons on the retina, sound waves in the ears, pressure on the skin. It cannot possibly show that raw data to the king. It's way too much noise, so it has to compress it all down into a single, simple, useful report. A headline. There is a red apple in front of you.
So red is the zip file.
Red is the feeling of that specific compression algorithm running. It's the user interface element, the icon, that represents that specific bundle of data from the outside world. Redness doesn't exist out there. Redness is what that data compression feels like from the inside.
That's fascinating. It's not that red exists in the universe. It's that red is the icon my brain uses for that particular wavelength of light, integrated with all my memories and associations of red things.
Exactly. It's a control knob, not a photograph.
All right, step 9, collectives. If we're all these isolated castles stuck behind our own Markov blankets, how do we have a society? How do we ever agree on anything?
This is chapter 14. Locher says a collective is a coordination layer, not a super person or a hive mind.
He has a phrase for it. Sovereignty without isolation.
Right. And this is a critique of a lot of modern political and technical systems. They try to merge the castles. They want a central hive mind server that owns everyone's identity and data. They want to tear down the walls so we're all just one big data soup. Locher says that's a recipe for fragility. If that central server crashes or gets corrupted, everyone dies. The whole system collapses.
So what's the alternative? How do the castles talk?
Through the webbed trust model. Instead of a central hub, imagine spider webs of trust connecting the castles. We corroborate each other's existence. I see you. You see me. We both agree that event happened. We verify without owning.
Verify without owning. That seems to be the key protocol for this whole system.
It is. It's what enables what he calls frictionless existence. Think about it. If my identity is computed and held on my device at my boundary, and I just need to send you a tiny cryptographic proof that says I am verified as over 21, you can trust me without needing to see my passport, my address, my birth date.
You check the proof, not the person.
Exactly. You check the derived claim. It's like zero knowledge proofs. I prove to you that I'm over 21 without revealing the raw data of my birth date. I maintain my boundary, I keep my sovereignty, but we can still transact and coordinate.
We are almost at the summit. We have built the physics, the self, and the society. This brings us to body part 5, the capstone, the very top of the infographic. Step 10, truth.
We made it to the top of the ladder.
But Locher's definition of truth isn't what I expected at all. He doesn't say, truth is what is real. He talks about structural honesty.
And this brings us full circle right back to the very first idea. Maps, not terrain. Locher argues that truth is not and can never be. My map perfectly describes the world. That's impossible. We can never perfectly describe the terrain because we are fundamentally stuck inside our own maps.
So what is truth then if it's not accuracy?
Truth is explicitly labeling your map components. It's admitting, with rigor, that you are using a map and showing how you built it.
The taxonomy. He breaks it down into 4 distinct categories. Let's place these at the very peak of our infographic.
Yes. To be truthful, a system, and this could be a human, a news report, or an AI, must clearly distinguish between these 4 things.
Observed. The raw evidence. I saw a flash of light.
Inferred. The best guess based on the evidence. It was probably lightning.
Assumed. The prior's the scaffolding. I assumed the laws of physics held true today. And number 4, convenient. The useful fictions. The sun rose at 6 a.m.
And we all know the sun didn't actually rise, the earth spun. But saying the sun rose is a convenient map, it works.
It works. And it's fine to use convenient truths as long as you label them as convenient. The lie, the structural dishonesty, happens when you claim the sun rising is an observed fact about the universe's movement. That's when you are misleading people.
And this leads to his ladder rule.
Never erase the ladder you climbed. If you present a conclusion, you are morally and structurally obligated to show the rungs, the observations, the inferences, and the assumptions that got you there. If you hide the ladder, you are manipulating the listener. You are presenting a finished map as if it were the actual terrain itself.
He makes a huge point about AI here. Why is this so critical for artificial intelligence?
Because an AI, especially a large language model, is the ultimate map-making machine. It generates text based on statistical probability. It is always, always inferring, not observing. It has no senses. If an AI gives you an answer but doesn't tell you this is inferred with 80% confidence versus this is a direct quote from an observed source, it is structurally dishonest. It's hallucinating reality by presenting an inference as an observation.
So Locker is demanding that a truly advanced AI must output confidence corridors, there's that idea again, and update conditions, not just flat declarative answers.
It has to say, here is what I think, here's why I think it, here's my confidence level, and here's the new data that would change my mind. That is structural honesty, and frankly, it's what we should be demanding from our politicians, our media, and ourselves. We have climbed the entire stack. We started in the void of pure relations, and we ended up at the ethical definition of truth. Expert, I want you to synthesize this for us. It's a lot to hold in your head. Can you summarize the full ascent? Walk us up that finished infographic one last time, in one breath.
Deep breath. Okay, let's do it.
We start with nothing but relations, because only differences matter. Boundaries form in that relational soup, creating individuals. Inference is what maintains persistence behind those boundaries. That's the verb of identity. That same inference engine compresses reality into user interfaces we call space and time. Topology provides stable, persistent intrinsics like charge and spin that live in that interface. So identity becomes our ongoing confidence in our own persistence. Consciousness is just hierarchical self-modeling to keep that persistence going against all odds. Collectives then coordinate through a web of trust using verified claims, not central control. And finally, truth is the discipline of keeping the map honest about how it was built.
Wow. That it actually holds together. It's a single unified theory. Physics, mind, and society are all the same fundamental pattern, just repeated at different scales.
It's fractal. That's the name of the book, The Fractal Core.
So the big question, the so what? Why should our listener, who might be a developer or a business leader or just a curious person trying to make sense of the world, why should they care about the reality stack?
Because it changes how we build the future. Right now, we are building technology that is actively fighting reality. We build these huge centralized identity databases that are honeypots for hackers. We build AI that hallucinates because it doesn't know the difference between a map and the terrain. We build security systems that annoy us with constant logins and friction because they don't have a concept of continuous persistence.
And Locker's saying we're doing it wrong because our foundational blueprint, our ontology, is wrong.
Exactly. If we align our technology with the reality stack, if we build these individually centric systems, we move from static identity to continuous confidence. We move from centralized data to boundary sovereignty.
And that's what leads to this grand vision he has of frictionless existence.
Imagine walking through the world where your digital life is as seamless and secure as your physical life. You don't log into your living room, you just walk in. Why? Because you have continuous coherence. Your body persists, your pattern persists. Your technology should treat you the same way. It should know you are you because of your persistent, coherent pattern, not because you typed a password you set 3 years ago.
It's a very hopeful vision. It's incredibly technical. It's deep. It's mathematically rigorous. But ultimately, it's a hopeful blueprint.
It's empowering. It puts the self, the individual, back at the center of the architecture, not as a user ID in some corporate database, but as a sovereign boundary that defines and defends its own world.
I want to leave the listeners with the final thought from Chapter 19. It's a line that really stuck with me as I closed this manuscript. He writes, "The terrain is relational coherence. Everything else is the map we build so an individual can persist."
It's a beautiful thought. We're all map makers, and we have a profound responsibility to make good, honest maps.
Thanks for climbing the ladder with us today. It was a steep one.
Keep your maps honest.
See you next time.